Hi, this is Apurv with a quick introduction to the Manzana case setup. When we approach problems, opportunities, cases, situations, our first step is to understand them in terms of flow and then use that understanding, step number two, to analyze and generate either qualitative improvement ideas or quantitative analysis and improvements. So the hope is that by this quick introduction, we will all arrive at a common understanding of what the flow is, which is the step one, and what the input numbers are, so that we can all devote our energies to actually analyzing the flow performance and improving and generating improvement ideas. The very first thing to notice that there are four different types of flow units in Manzana: runs, reruns, wraps, and rains. And what we're going to do, what we're going to start with, is by combining all these four units into this, what I'll call a combined or an average or a typical, just one type of flow units. And later on, we will think about how to separate them out, but we are going to start with one typical combined average flow unit. And in terms of thinking about inputs, the very first question is, what's the arrival rate of this typical flow unit? And the number, that's the number we are going to use, is 39 per day. That number is coming from the one of the exhibits in the case, and I'll show you exactly how to get that. Those arrival units then get to the first station, which is the distribution station, and there are four resources given in the case. And the case also, one of the exhibits in the case also says that the service time is 41 minutes at that station. As the units output from station 1, they get distributed into three different regions, and there is an underwriting team for each of these three different regions. So this total arrival rate of 39 has to be distributed between these three different regions underwriting teams. And I'll leave it to you to look at the case, the data given in the case, and determine what exactly are the arrival rates at each of these three stations are. They will add up to 39, but what's the fraction at each region? Once the units go through station number 2, which is underwriting team, then they get combined again, and we are back to our 39 per day arrival rate. And then it gets to station number 3, which is the rating station. There are 8 resources as given in the case at the rating station, and the service time is given as well. The next station is policy writing station. Most of the units, at least 3 of the 4 types of units, go straight to policy writing. That is this flow. But the wraps, only a certain fraction of wraps arrive at the policy writing. So the question marks here refer to the number of wraps and then what percentage of that wraps arrive at the policy writing station. So the sum of directly arriving flow units and some of these wraps that are arriving at the policy writing units will give us the total arrival rate at the policy writing, and I'll let you determine that looking at the data in the case. There are 5 policy writers, and the service time is given here, and then the units output the flow. We will think of the flow from here to here, and we will try to determine the total time a typical or an average unit have in this flow. Okay. I hope this offers a common visual of what the flow model is and tells you some of the major input numbers, but it still leaves some things for you to determine by yourself, which I hope would be possible. On the next slide, I have some of the details of these calculations. I have been referring to these numbers, and here they are. So the number 39, that is the total arrival rate, as I offered on the previous slide, is coming from the data from the exhibit called processing requests in the case. And what that table shows in the last columns over 6 months was the total number of different types, runs, reruns, wraps, and runs came over 6 months. So what I've done is that taken numbers from there, total across all regions, and added them up here, and then make some assumption about number of days in a month to give me a total of 39 per day that I have been using on the previous page. Now you could take the same data in the same exhibit and try to determine the same arrival rate, a similar arrival rate for each of the three regions. And you could also think about the product mix based on these numbers, what fractions of each type are there in each of these units, and hopefully they'll be useful for further analysis. I'm also assuming that there are 7.5 hours in a day, and at the policy writing stage, I'm requesting you to compute, to think about that not all wraps reach policy writing, and find relevant information in the case to estimate the arrival rate at the total arrival rate at the policy writing stage. The service time numbers that I gave you on the previous slide directly come from, I can directly read these numbers from the exhibit called policy processing times, and you would be able to find that in the case. The next important thing, or the only important thing in terms of input that is left, is what are the C numbers. We are talking about variabilities, and we want to determine how these variabilities impact the performance of the system. The variabilities are captured by C numbers. There are two types of C numbers. C sub A is the representation of a variability in the arrival process. And at each step, we are going to assume that the C sub A, the coefficient of variation of the arrival process, is 1. So we can use that as the input. There is more data in the case about the coefficient of variation of service time, which measures the variability in the service time. The exhibit policy processing times not just gives the average service times, but also gives standard deviations of service time. So the request is that please read the case to determine, to identify what the standard deviation numbers are. And then I'm proposing here a simple scheme to try to combine all these standard deviation numbers, because the exhibit gives standard deviation numbers for each type, while we are looking for a standard deviation number across all 4 types for our typical or average unit. So the rest of the point 3 here suggests a way to combine these different standard deviation numbers into one, and then try to compute a common standard deviation and therefore a common C sub S number across all 4 types. If this is a little bit confusing, what I'm proposing here, then I would suggest that please go with the alternative of C sub S equals 1, which would not be a close capturing of what the case is suggesting, but would be a reasonable approximation to move forward. And then finally, once we have this, then we can all these numbers, then we realize that at each of these steps we have the arrival rate number, we have the service rate numbers, we have the 2 C numbers, and therefore we can use the wait time spreadsheet to compute the waiting time and also the total time at each of these stations. And once we add all of those total times across each of these 4 stations, that would be our total flow time measure, which the case is referring to as the turnaround time, and that is the number we are looking for. It's very likely that the TAT, or the turnaround time that you get from based on what I'm proposing here, would not exactly match the number that is given in the case, and that's okay. We can discuss why that is different. But I hope this is enough of a starting in terms of what the flow is and how to get these input numbers to start the analysis. I hope this provides enough of a background for all of us to start from a common platform and compute a turnaround time number. Any questions, any doubts, any confusions, please email. I'm always available to answer questions. Thank you for listening. Bye.